Hello, I'm John, and welcome to this intermediate JavaScript tutorial series. I'll be going over some JavaScript principles that a junior front-end engineer should know. So whether you're looking to get your first job or just brush up and keep your JavaScript sharp, I hope you enjoy the content. What I'll be covering today are JavaScript types and references, and doing some code demonstrations to point out some of the weird parts about them. So if you get something valuable out of this video, feel free to give it a thumbs up, leave a comment, and subscribe if you want to get more information like this in the future. All of the content for this video will be found on this GitHub repository that I'm creating for this series. I'll leave a link in the description. If you want to download it, you can always just download it here, or if you're comfortable with GitHub, feel free to clone it, and as the updates come, you can pull the new changes. In this first lesson, I'm just including one file, typesandrefs.html. So feel free to download that, double click to open that up in your browser, and you'll see a lot of information about it. Where I've already opened it up and opened up a console, you'll just see the information itself. So feel free to open up your console as well, because there will be a JavaScript portion of it that goes hand in hand with the information that you find on this document. Now, as I said, we'll be going over types. And just as a brief reminder, JavaScript types are broken into primitives and objects, where you have Boolean strings, numbers, big ints, null, undefined, and symbols, and then the objects, which includes things like arrays and more complicated structures that are all built on that object type. Now, one of the biggest differences that's important to know regarding the difference between these primitives and objects has to do with literals versus references. Now, literals are the instance of data structures, while references point to them. So a primitive variable is always going to be passed by a value, it's literal, while objects are passed by reference, and those references are pointing at the data. This prevents unnecessarily large copies of the objects from being made. So let's go over to this picture I created here to see a visualization of what I'm talking about. Now on this top half, we're creating a variable a and setting it to 7, visualized over here to the right. A is set to 7. Then we're saying b is set to a. And this is showing what's going on behind the scenes in JavaScript, where we're making a copy of that value 7. And b is set to 7 again. So for example, if we're saying a is now set to 14, although we said b was set to the value of a, b is still going to equal 7 because the value was copied, not the actual reference to that value in memory. Now, objects are not treated the same way. So let's say, for example, we're setting a to this array. What we're actually doing is creating an empty array and referencing that array from a. So if we then say b is set to a, we're actually copying a reference to that array from a, which means if we add the value, say 7, pushed into that array, b is also going to see that same array that's no longer empty. So once you get your head around that, it's not too difficult to understand the distinction between the reference and the values. But what would be a practical example? And for that, I added some code in this file here, and I put it all inside run examples. So we'll run that in the console, and it's going to spit out a bunch of different console logs that are related to the code that I put in there. And this first one is talking about how functions that return computed information about their arguments. And this is important because when you're calling a function, it's always creating a variable of the arguments. And what we talked about with literals versus references applies directly to that. So let's look at the code to see what's going on, and then we can kind of analyze what's output in the console. So first up, we're defining 3 variables: number variable, string variable, and array variable. And then we're creating a function that gets the values. After that, I'm creating 3 different functions that are taking their argument, changing that argument. So in this case, we're doubling a number, we're adding a last name to the string, or with the array, we're going through each value in the array, and we're doubling that. So we're changing this argument, xvals, and then we're returning that back. So if we run getVals again, it's going to tell us the values of the array. So then we'll run getVals to say what all these variables are, followed by calculating the values of those functions that we wrote. After that, we're going to get the values again and see that there's a problem. Now, as you saw in the code, number variable 7, string variable John, array variable 1, 2, 3. When we calculate those values, everything does check out. Double 7, 14, we're adding Geiger to John, and we're calculating the double values, 2, 4, 6, which is double, obviously, 1, 2, 3. But the problem that we see here is that when we print out the values of those variables again, number variable is still 7, string variable is still John, which is correct, but array variable also was doubled, which is not what we wanted. All we wanted to do was calculate the doubled values in that array and not actually change the original array. So what I did was write a simple solution that fixed the problem. So what I'm doing with calc double values 2 is copying this xvals to xvals copy. And this is essentially syntactic sugar for taking all of the values in xvals and just putting it into a new array, which is then being referenced by xvals copy. So after that, we can return calc with doubled values 2, and we're only going to be doubling this copy of the array, which means xvals is never actually going to be changed. And if we look at the logs, the first time we run it, it was set to 2, 4, 6. But now if we run it again, we're getting 2, 4, 6. And that means that the array was not changed again. And so that means that we were able to get the values of that doubled array without actually changing the initial array, which is what we were looking for. So the next example has to do with React. So I didn't actually put a code example just because not everyone necessarily is expected to know React. But if you are a React developer, it has to do with hooks. In React state hooks provide a value and a setter. So if an array is stored, you have to use a setter to change that variable. And what that means is if you're going to change an array with React state hook, you're going to have to make a copy, change what you want in the copy, and then set that value. If you don't know React, you don't have to worry about that. But what if? So this next part has to do with variables and checking if they're true or false. What do I mean by that? Well, if you're going to say if and then a variable, everything is viewed as if true or false, then do something. And so what I did here was create a bunch of variables of a lot of the different types that we talked about. So I'm creating a 0 number, a negative number and a positive number, empty string and a not empty string, as well as objects, arrays, null variable, an undefined variable, and a never defined variable, as well as true and false. I then wrote a function called equals true, which is giving you the value, the type of the value, and then it's telling you whether that value would be calculated as true or false. So what's going on here with these 2 exclamation points? Well, you might be familiar with using just 1, which is finding not of the value. And so what 2 is doing is it's saying not, which is going to tell you if that value was calculated as true or false. So if you take the number 1, for example, 1 is true. But if I say to log 1, this variable, it's not going to log true or false. It's going to log the actual value. So I'm saying not 1 is going to be false. Not 1 is going to give you true again. So that's just a way of knowing whether that value would register as true or false through an if block. So what I essentially did was log all of those out, and then we can look at some of the findings. Now, if we look here, we've got the number 0 is false, whereas every other number, both negative and positive, is true. Strings, we've got an empty string being false, normal string true as we would expect. However, when it comes to objects, it's always true. So an empty object is true, an empty array is true, and if those objects have values, as we would expect, also true. Null, undefined, and never defined. Yeah, so what I did here actually is define these variables as null and undefined, as well as creating this variable never defined and just not setting a value. What we see there is that it is undefined, and as you would probably expect, all of them are false. And just as a sanity check, I included true and false, and yes, true is true and false is false. Some notable findings is that the number 0 is treated as false. Empty strings are also treated as false, but empty arrays and objects are treated as true. What this means is that you should never test the existence of a number based on just saying if that number, then do something. You should always check the type of what you're looking at so that you know what you're working with. Now, references, on the other hand, as I said, those are just always treated as true. And it's worth keeping that in mind. Just because an array exists doesn't mean there's any information inside of it. So now let's do a little example in the console to go over how you would want to check data that you have to properly cover your bases on, say, an if check. And for this, I'm going to imagine that I'm getting information back from the server in a web store, and I have to render all the objects that have an account ID, and if an object does not have an ID, well then don't render it. So in this case, I'll just create constant object1, and that is going to have an ID of 1. I'll also create object2, and that has an ID of 0. Object3 will say has no ID. Great. So now what we can do is create a function that will tell us if we should render this whatever object is passed to it, just as sort of a sanity check so that we know that our logic is correct before we render. Function should render is going to take an object, and we will say if object.id, then console.log render me. And I'll say else console.log don't. And we just have to add closing off that else. Great. Now this function is not actually what we want. Why is that? If I say should render object1, it's correctly telling you not to render you. If I say should render object3, saying don't. However, if I say should render object2, it's also saying don't. Why is that? Well, it's exactly what we covered earlier. That value is 0, which means it's viewed as false. Another way we could write this function is instead of saying if object.id, we can use type of and say if type of object ID equals a number, then render it. Otherwise, if it's not a number, if the type is undefined, if the type is null, then don't render it. So does object1 still work? Render me. Does object3 still work? Don't. Does object2? Render me, which is exactly what we want because it does have an object ID. It just happens to be a number, 0. Just to kind of cover what we went over today again briefly, we've got two different main types of data in JavaScript. We have primitives and objects. Objects are going to be passed by reference, where primitives, the literal value. We looked at how it's important if you're dealing with objects to know if you're changing the value of the referenced variable versus making a copy, changing the copy, and knowing that the original data is safe. I talked a little bit about the implications in React, and then we looked at some interesting examples of how objects are viewed in an if check and ways to properly check your data depending on your own needs. I hope you got some meaningful and actionable information out of this tutorial. If you have any good feedback, things that you think I could do better, things you'd like to see, feel free to leave a comment. And if you enjoyed what you saw, give it a thumbs up. If you didn't like it, big fat thumbs down. Feel free to subscribe if you want to see more and get notified of new videos. And thank you for watching. See you next time.